That's all you get for the music just today. So our lesson today is about isosceles and equilateral triangles. So we're going to talk about triangles that have two sides congruent, an isosceles triangle, and triangles that have three angles congruent, equilateral triangles. So let's get started. An equilateral triangle has three congruent sides, just like I just said, and an equilateral triangle has acute angles. It cannot have obtuse angles. So we're going to circle the equilateral triangle in your thing, and it's the one behind my recording button, so that's not going to show up, but that's the one you want to circle. So let's continue on in our review. Isosceles, a triangle is isosceles if it has two congruent sides. So in our picture we have an isosceles triangle and an isosceles trapezoid. The angles and sides of isosceles triangles have special relationships. So I'm going to have to move my record button here because we're all in the way. Okay, so use the triangles below. Write the letter of each triangle in the correct circles at the right. So the only equilateral triangle we have in the picture is which one? That's right, triangle D. The isosceles triangles that we have are A, B, and D is, if it's equilateral, it's also isosceles, and E. And finally, the right triangle we have in the picture is C. A and C, excuse me. Missed that little right triangle symbol in A. So we have three new theorems for tonight's lesson. It's theorem 4.3, 4.4, and 4.5. 4.3 deals with if two sides of a triangle are congruent, so I have two sides of the triangle congruent, then the angles opposite those sides are also congruent. So my two legs are congruent and the base angles are also congruent. We can also look at the converse of the isosceles triangle theorem, which is if two angles of the triangle are congruent, there are my two base angles, then the sides opposite those angles are also congruent. And finally, our last theorem, theorem 4.5, if the line bisects the vertex angle of an isosceles triangle, so there's my line that bisects the vertex angle, then that line is also a perpendicular bisector of the base. So the green line there has, if I label the points A, B, and C, AB would be congruent to BC, or equal BC, let me say it correctly. So if lines bisect the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. Continue on. So if PQ is congruent to RQ in triangle PQR, that means my vertex angle is angle Q, then angle P is congruent to angle R, and angle Q is the vertex angle. Now we're going to underline the correct theorem number to complete the sentence. If CD is a perpendicular bisector, then AD is congruent to DB, and that is theorem 4-5. All right, so let's use these theorems and put them into action. So first, using the isosceles triangle theorem. Is angle WVS congruent to angle S? So WVS is this angle right here. This is angle S, and I want to know if those two angles are congruent. TR is congruent to TS, so this segment is congruent to TS. And so we're going to look at what else is shown. So the markings show that WV is congruent to WS. So our question is angle WVS congruent to angle S? And obviously it is, yes, because if you have a triangle with the sides congruent, WV is congruent to WS, angle WVS is congruent to angle S, so they are congruent by the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent also. All right, is angle R congruent to angle S? Well, the answer to that one is also yes, because angle R is congruent to angle WVS. There's a lot of ways, well, it's given to us that that's the case. And angle WVS is congruent to angle S. So by the transitive property of congruence, angle R is congruent to angle S. And now last but not least, we want to see if segment TR is congruent to segment TS. Well, that was a question up there, and I stated it like it was true. So we know if TR is congruent to TS. Well, yes, because if angle R is congruent to angle S, then segment TR is congruent to segment TS by the converse of the isosceles triangle theorem. If two angles of a triangle are congruent, then the sides opposite those angles are congruent also. So let's use some algebra. We can solve equations and problems when we use looking at isosceles triangles and equilateral triangles. So suppose the measure of angle A equals 27. So this angle right here, angle A equals 27. What is the value of X? Well, if we know that angle A is 27, since CB is congruent to segment AB, and that's given, we know that triangle ABC is an isosceles triangle. So we know that angle A is going to be congruent to angle C. So since triangle ABC is isosceles, the measure of angle A equals the measure of angle C, which equals 27. Since BD bisects the vertex of an isosceles triangle, that means that BD is perpendicular to AC, or should be AC. My apologies. Hate when I make a mistake, I really do. So that should be a C there. Make sure you make that correction. That should be a C. There we go. I'm going to correct it because I hate making mistakes. All right. And the measure of BDC equals 90, obviously, because it's definition of perpendicular bisector and definition and right angles equal 90 degrees. So we know, using the justifications below to find the value of X, we know the measure of angle C plus the measure of BDC plus X equals 180, and that's by the triangle angle sum theorem. The measure of angle C is 27. The measure of angle BDC is 90 plus X, that equals 180. So we're going to simplify. That's 117. Subtract 117 from both sides, and we'll get 63. So the measure of angle X is 63. All right, let's continue on. We have corollaries. A corollary to a theorem is something that's associated to the theorem, which we also have to prove is true, but it's basically based off the theorems that we've already proved. So the corollary to theorem 4.3 is this. If a triangle is equilateral, then the triangle is equiangular. It kind of makes sense. If all three sides are congruent, then all three angles are congruent. And then the corollary to theorem 4.4, which is the opposite, if a triangle is equiangular, it's easy for you to say, then the triangle is equilateral. So we're going to underline the correct number to complete the sentence. The corollary illustrated below is corollary to theorem 4.3. If a triangle is equilateral, then the triangle is equiangular. So finding angle measures. Again, some more algebra. Suppose the triangles at right are isosceles triangles where angle ADE, DEC, and ECB are vertex angles. If the vertex angles each have a measure of 58, what are the measures of angle A and the measure of angle BCD? Okay, so which triangles are congruent by side angle side theorem? That's going to be triangles ADE, DEC, and ECB, because all the vertex angles are congruent in the two sides, so it's side angle side. So which angles are congruent by the isosceles triangle theorem? We know that angle A and angle DEA are congruent, angle EDC and angle ECD are congruent, and angle CEB and angle B are congruent. So let's go ahead and finish up this problem. So by the triangle angle sum theorem, the measure of angle A plus 58 plus the measure of angle DEA equals 180. All right, we're going to solve for the measure of angle A. So since the measure of angle A and the measure of angle DEA are congruent, we can say twice the measure of angle A plus 58 equals 180. Twice the measure of angle A equals 122, just subtracted 58 from both sides. And so the measure of angle A equals 61. So since angle A is congruent to angle ECD, the measure of angle ECD is 61. We can use the angle addition postulate, since the measure of angle BCD equals 58 plus the measure of angle ECD, we know that it equals 119, because 61 plus 58 is 119. So let's quickly do our lesson check. It's a basic lesson, just what do you do when you have isosceles triangles and equilateral triangles. We do a lot of problems with mathematics, with algebra with these type of problems, and the theorems are pretty basic. So what is the relationship between sides and angles for each type of triangle, for isosceles triangles and equilateral triangles? Remember that an isosceles triangle has 2 congruent sides, while an equilateral triangle has 3 congruent sides. The isosceles triangle theorem states that the angles opposite the congruent sides are also congruent. Equilateral triangles are also isosceles triangles. Just something we have to remember. The sides and angles of an equilateral triangle are congruent. So equilateral triangles have congruent sides and congruent angles. So that's our lesson for today. Tomorrow when you come in, we'll work on 4-5 and do some problems with equilateral and isosceles triangles. And we have a little extra time. We will work on our projects, the bridges. And so if you do have materials, make sure you go ahead and bring them in so we can work on those. And there's my music for the night if you wanted to know who it was. Hope you have a good evening. See you tomorrow.